All right, so now that we understand 3 types of ERD, which is physical, logical, and conceptual, now it's time to dive into the relationship types and what really drives a relationship. Check this out. So when you hear someone say, how does this table connect? Is it foreign key, is it primary key? What they're really asking is, what is the relationship type and what is it connected by? So is it one-to-one, one-to-many, many-to-many, or something else? We're going to talk about all of them in detail so you can see it for yourself. So there are more advanced ones. We're not going to talk about all of those just yet. We're going to keep it pretty vanilla, talk about the ones I mentioned in intricate detail. So a one-to-one relationship exists when one entity instance corresponds to exactly one instance of another. So this pattern is used when data is split across tables for privacy, security, or performance. And it helps separate sensitive or infrequently used data into different tables for security and performance. This also reduces risk while keeping the model data clean and efficient. So here we have the person ID and we have the license ID as well. So they're both the same person, right? Because you can only have one license. So only one person is connected to one license. So that's just an example of one-to-one. And you may see something like this you're doing right now in Power BI or some other application, but this is just a way I did it within DB diagrams. And I'll actually show you that later down the road as well too. All right, so next up we have is one-to-many. So as you can imagine, it's one unique person, so one customer ID connected to many orders that the customer may have. So you're always going to have one ID associated to that person, and they can go in just like Amazon and make a bunch of orders at any time, right? So it's associated to them in that manner. All right, so many-to-many gets a little bit more complex, and there is some risk involved here too. But they capture associations where both sides can link to multiple instances. These are implemented through a bridging or associative table in physical models. It captures complex relationships where multiple entities interact with multiple others, such as enrollments, assignments, or memberships. Without it, critical business rules become impossible to express. So let's talk this one through, right? So you have a student ID, which is unique. You have a course ID, which is unique. But we know students change out, courses change out every semester, right? Even within a semester. So students enroll in many courses, and courses have a bunch of students. So we have a bridging table that connects both of them together, creating a many-to-many relationship because there are many of both of them. So this one's kind of unique too. We have recursive relationship. So imagine you're in a company or an organization and you have a manager and employees under them. So each manager is going to want to know all the details about their employees. And you may not have separate tables for it, and now you have a master table associated with all the information. And within that table, you have the manager information associated to the person. So that manager may be duplicated within that table simply because they're a manager for more than one person. And this is where that relationship connects internally within its own table. So this creates an entity related to itself and creates a hierarchy within the same table. It allows modeling of hierarchies like reporting structures, product assemblies, or organizational change. These patterns appear everywhere in business data. All right, so next up we have this ternary relationship. It's going to be a relationship that captured a rule involving 3 entities at once. So none of the binary combinations can fully represent the business rule by themselves. It captures rules that cannot be represented using only 2 entities. Ternary structures enforce correct business logic when interactions depend on 3 parties at once. So here we have a supplier that's going to deliver a part to the warehouse. So all 3 of these are kind of connected together, right? And they're unique in their own, but none of them are actually talking to each other in a full delivery concept, right? Because all of them flow to the delivery, which is the end state. So delivery connects to all of these other ones. But without one of them, you can't have any of them, right? Which is where ternary kind of comes into play. You can do the same thing for healthcare as well when it comes to the patient, the invoice, the tracking, etc. All right, so the next one we have is N-ary. So it's a relationship similar to Ternary, but it involves 4 or more entities participating in a single combined rule. So it supports complex multi-dimensional events that require more than 3 entities, and this prevents incomplete or incorrect modeling of real-world processes. So here we have doctor, we have patient, we have medication, and then we have the visit event. And the fourth one that you're really looking at is going to be that visit date here, right? So we have the other 3 that are mentioned before, and the visit date, and then all that brings into the visit event that stores all the information. That's where that 4th table truly comes in. All right, so next up, and the last one we're going to cover is going to be supertype and subtype relationships model inheritance. So shared attributes are stored in the supertype while unique attributes belong to the subtypes. So as you can see, the car, the truck, the motorcycle all have vehicle IDs, right? And that's stored within the vehicle table that you have here. But what's independent here is going to be the VIN, the license plate, and the type. And this one reduces duplication by grouping shared attributes while preserving differences across specialized categories, meaning car, truck, or motorcycle. And this makes the model cleaner, more scalable, and easier to maintain. And then as you can see, there's some things that are very distinct about trucks, which is cargo capacity. That's not loaded into the vehicle table, nor is the engine displacement of the motorcycle as well. So they're unique in nature, but they also share an attribute, all of which fill the vehicle ID within the vehicle table. Now, to be honest, the main ones you're probably going to utilize is going to be one-to-one, mostly one-to-many, and then some many-to-many as well. The other ones you probably won't be using as much, but it is good to know. Doesn't necessarily mean you have to remember the exact vernacular, just the concept as a whole. That's what really matters. As long as you can talk about it, speak about it, and demonstrate it, it really doesn't matter if you know the exact book terminology that's out there. So with that said, the next video we're going to talk about is a crow's foot symbol, what they mean, and how they impact you within your database. But as always, leave a comment. Let me know your thoughts down below, and thanks for watching.